All right, so let's look at another form of concentration here, and that's mass percent. So again, a couple units ago, we talked about what mass percent is. Just to refresh, mass percent is grams of solute over um, grams of solution. And we multiply all that by 100 to put it into a percent. And so that's going to be our, what we're going to use as a conversion factor. So let's take a look at this problem. So we have a rock that is 32% iron oxide by mass, and it reacts with carbon monoxide in the reaction that's shown there. How much iron, how many grams of iron can be produced if we have 125 grams of the rock? Now, first thing that I want you to note is that 125 is not 100% Fe2O3, because the first statement that is there says that the rock is 32% iron oxide. Now, what does that 32 mean? That means that if we had, let's just say we had a 100-gram rock, that 32 grams of that would be iron oxide. There's our conversion factor we're going to use. All right, so what we have to do first is get to mass of A so that we can get to moles of A, and then we can get to moles of B, and finally mass of B. So the only thing with mass in it right now is we're starting with 125-gram rock. And is there any way to put that into one of our reactants? Well, we just said that 32 grams of iron oxide are in 100 grams of the rock. So those cancel out. Now I'm in grams of A, iron oxide. How do I get to moles? Well, 1 mole of Fe2O3 has a molar mass of 159.7 grams. Now, again, the problem gives that to you, but you should be prepared to find that molar mass on your own. Now you'll notice I'm in moles of A. How do I get to moles of B? I'm going to use the coefficients from the balanced equation. This equation says 1 mole of iron oxide will produce 2 moles of iron. So now that I'm in moles of B, I can finally get to mass of B by using the molar mass. So from the periodic table, 55.85 grams of iron is 1 mole of iron. Everything cancels out correctly because I'm left with the unit I want to go to, grams of iron. So I'm going to toss all of that into my calculator, and I get a value of 28.0 grams of iron. All right, and let's round out this first series of discussions by looking at how I can use density to get where I need to go. Remember, again, the key thing is get to moles. So how do I use density in order to figure that out? Well, remember, density is usually mass per some volume. If I know the volume, then I know the mass. If I know the mass, then I can get to moles. So in this reaction that's described here, we're going to take ethanol and burn it in the presence of oxygen to make carbon dioxide and water. Now, I want to emphasize the difference here between this problem and one we used earlier when we talked about molarity. This problem deals with a pure substance in the liquid form. That's not a solution. A couple pages ago, when we were looking at molarity, these were solutions, a solute dissolved in a solvent. When we have a pure liquid, then we can use the density of that to figure out the mass of that liquid. All right, so ethanol is going to be our A, and we're going to figure out how much carbon dioxide is present. The central theme is get to moles. Well, what do I need here to get to moles? I don't have concentration. Somehow I got to get to mass in order to get to moles. And the way I can get to that mass is by using the density if I'm given the volume. Okay, so let's start with that. You notice here that at the very beginning of our flow chart here, we're starting with volume of A. So 10.8 milliliters of ethanol. This is just my organic chemistry lazy shorthand for ethanol. And I'm going to use the density. The problem says that there are 0.789 grams of ethanol in 1 milliliter of ethanol. So those cancel out. Notice what has happened now. I'm in grams of ethanol. And so all I have to do is use the molar mass, which I'll write that up here. The molar mass of ethanol is 46.07 grams per mole. And let's do CO2 while we're at it. All right, so I'm going to get to moles of ethanol by using the molar mass. Okay, so notice I'm at moles of A here. How do I get to moles of B? Use coefficients from the balanced equation. 1 mole of ethanol produces 2 moles of CO2. And then finally, how do I get to grams of my product of CO2? I use the molar mass again. 1 mole of CO2 weighs 44.01 grams. If I've set this up correctly, the only remaining unit is what I want to go to, grams of CO2. So I toss all of that into the calculator, keeping track of my sig figs, and that gets to 16.3 grams of CO2. I highly encourage you to start practicing some of the problems that I've posted up on Canvas. Work on problems that are in your textbook. You have access to the solutions manual. I put a link to that in the extra resources page on Canvas. So you have plenty of tools at your disposal to master this concept of stoichiometry. Because what we're going to start off with in our next day of lectures is getting into what happens if I don't have enough of one of my reactants. Let's go back to the pancake example from the very beginning of this day. If I wanted to make 24 pancakes, I needed 3 eggs. But what happens if I only have 2? How many pancakes am I allowed to make? And that's where we're going to be going with this, and we're going to put it in more in terms of chemical reactions.